Good morning. It's Wednesday 10 a.m. And as usual, we have our fireside chat with the experts. Today, my colleague, Dave Phillips, is going to talk to us about PM or not PM, if that's really a question, right, Dave? It's all yours.
It's not really a question. It's an easy question to answer.
You go ahead.
Okay, thank you. Hi, and welcome back. I hope some of you have joined us before. And again, my name is David Phillips. I'm the VP of Customer Care with Creative Electron. And again, the title of our chat today is to PM or not to PM. Is that really a question? And to give you the hint, it's not a question. We're going to, answer that, but yes, you always want a PM. So let's get right into the presentation, and then we'll take some questions at the end. So let's define what a PM or preventative maintenance is. And a preventive maintenance service is very similar to a tune-up and a safety check on your car. Sometimes we use that acronym and people don't say, what's a PM? So in a car, you're looking at the fuel system, the emissions, the ignition, the cooling system, the body, and making sure it's all performing correctly. With an X-ray system, a cabinet X-ray system, we're looking at the cabinet, the frame, the integrity. We're looking at the X-ray source. We're looking at the detector, the camera, the image processor, and then also the manipulator, what the sample you're looking at. So all of these systems work similar, and we're looking to do a tune-up on it. And then we're going to do a safety check and make it sure it works to specifications. So some of the cabinet, TruView cabinets or cabinet X-ray systems that you might be familiar with are what we manufacture. The TruView currently, we have the Cube, which is a small desktop unit, which has a 6x6-inch sample size and manipulator. Then we have its big brother right next to it, the TruView 5, which is a tabletop unit also, or it can be placed on a cart. And that has the ability to have a sample up to 12 by 12 inches. Uses a flat panel detector as opposed to that smaller cube where we use an image intensifier. Then we have our floor model unit, the Fusion, which holds a standard sample of 20 by 24 on that. All of these systems have the ability to use different variations of X-ray source power. So we can use anywhere from 80 to 150 kV systems in the Fusion, the Prime 80 to 130, and the Cube 80 to 90 kV. And then we have off to the right our parts counter, which does inventory control and counts reels. Some of the legacy systems you might be familiar with, or we've done a PM on, or you've seen before, are pictured here. So over to the right, or excuse me, to the left, are the focal spot systems, which I was originally came from, and Focal Spot was purchased by Creative Electron in 2016 and became part of the Creative Electron family. So there's about 300 plus of these systems out there. The Verifier and the Insight series, and a few little variations of that. A very popular model in the 90s was the Nicolay X-ray systems. This is kind of the Kleenex of X-ray systems that all of your contract manufacturers and bigger OEMs on this, and there's probably about 3,500 of those systems. Down towards the bottom on the left, you have the Glenbrook RTX series, which is a very popular low-cost system. You have the CR technology in the late 90s with their CRX 2000, and then a similar unit, the Faxitron, to the Nicolay X-ray imaging systems. So again, I just wanted to point these systems out that may have been serviced by you, or you have it, or you have questions on that, and then we provide service. So on a preventative maintenance, the main thing we want to talk about, or well, the utmost at the top of the list, is safety. So we want to make sure the cabinet is radiation safe. So if you take a look over onto the right, you see a lead door on an old Nicolay system with a cracked lead, some delamination. So this may compromise the integrity of the cabinet and expose the user or the operator to something that's not radiation safe. We use on most of these systems, they have a leaded glass window. So if the glass is cracked, that again can compromise the integrity of the system and have a radiation issue. And off to the left, we have one of our creative electron systems where this system was actually dropped from a second story storage bay, and it's actually listing to the left. So this cabinet has been compromised. So again, safety, we want to ensure all the cabinets, the integrity of the lead and the construction is with intact and not causing any issues. That term ALARA on the top, that's as low as reasonably achievable. So we're always making sure in cabinet X-ray systems that the system is with concern to exposure of radiation is as low as reasonably achievable. Continuing on to safety, we talk about safety, all of the interlocks of the system. So the system has on a door usually dual interlocks. If either, it's required to have dual interlocks. If either of those interlocks fail, the X-ray system can't be energized. We want to make sure that those both are working correctly when the door is open. If the door is open, the X-ray is cut off immediately. We have proper grounding, and this is grounding, electrical grounding for the system to prevent electrical shocks. And also we have grounding for ESD devices to make sure that they're not damaged. We want to make sure the e-stop works, that turns off the X-rays. We want to make sure the X-ray on and off buttons work, the indicator lights on the control panel on the tower work, and the motion safety. And that would be motion safety more on the manipulator, if the manipulator needs to stop when the door is open, or it can't be moved, such as when conveyors could require a pinch hazard, or somebody could place a arm or a leg into the X-ray system and have some unduly exposure. So on our cabinet X-ray systems, this is the regulatory requirements. That falls in the US, falls under the Food and Drug Administration. And this happens to be for Code of Federal Regulations, Title 21, 1020.40. And this defines what a cabinet X-ray system is, okay, what the safety requirements, and what the radiation exposure limits. I've also included a link to that after, if you want to take a look at it. It has the 4-page document, and again, it talks about the regulatory requirements of a cabinet X-ray system. And to sum it up, those FDA requirements for preventative maintenance, we do yearly radiation checks and follow the manufacturer's recommended schedule. So we happen to be a manufacturer, we do recommend an annual PM and radiation survey, but a lot of our customers are looking at doing it semi-annually or even quarterly, depending on the usage of the machine and their safety requirements, internal safety requirements. Radiation limit within the US, based on these FDA requirements, is 0.5 MR at 5 centimeters from the surface of any of the cabinet using a radiation survey mirror. It needs to have an X-ray on light, that dual interlock on the door that we discussed, both working independently, an emergency stop to stop the X-ray source from emitting X-rays or X-ray photons and radiation, and a removable on-off key to make sure somebody doesn't use unauthorized use of the system. As we talked about the federal regulations, we have examples of the state requirements, and most of the states follow the federal regulations, and they may be more restrictive also too, just depending on how they based on their Department of Health and what they feel is safe. So I've actually put a posting of a violation, and it shows 2 of the state requirements in California. And this was an actual customer, and we blotted out the name, but to show you what some of the violations, and these states actually do these inspections. So this is Title 17, Section 30337, and this system did not meet. If you can see on the 3rd paragraph in A, this system didn't meet the radiation requirements of the 0.5 MR per hour, and it was a violation. The second one was they didn't test the interlocks annually to ensure that they function. So these were 2 violations. There's several more pages. So if they didn't keep their preventative maintenance up, you can look at a possible violation. So we came in, corrected these, and then they were able to resubmit and then make repairs, resubmit the violations, and say they were corrected, provided a corrective action, and then it began to use the system again. So after we've talked about the PM and the radiation survey, we talked about what we actually do on each section when we do that preventative maintenance. So we'll look at a cabinet inspection, the control panel user interface, the electrical test, the motion and manipulator conveyors testing, X-ray imaging train, again, the safety interlocks, and then radiation survey. And then if we have time after we've done all of the preventative maintenance, what we like to do is give the user training and operator. So again, on that PM and radiation survey, the task we're looking at, are we looking at that cabinet? We're looking for the entire cabinet, top to bottom, cracks and damages, lead delamination. So if you look at this cabinet that had been dropped, we can see in that area where the lead layer between the 2 steel is no longer connected and also bent. So we know there's an issue there. Obviously, this is a gross issue on that, but we want to see a lead delamination. Maybe lead has been welded or has adhesive and it's being removed or falling down. And so we want to make sure that, again, the integrity of the cabinet to avoid any unnecessary radiation exposure, and that it's within those limits. The control panel, on the bottom, you'll see a graphical user interface with one of our TruView systems. On this side over here, you can see the X-ray on indicator on the computer. It also have a tower light, but you can see the KV and the MA readouts for the source, and then also the X-ray on, off, and then the manipulation controls. So we want to make sure all of those work correctly. Once we've checked that on the system, we're going to do electrical tests. So first thing we're going to do is grounding. We're going to make sure the system is electrically grounded correctly, so we prevent any electrical shocks. And then also we're going to test the system for ESD grounding to make sure we don't damage any components that we're inspecting. After that, we've done our grounding tests, we look at source voltage checks. So we're looking at the X-ray source, and we're going to test the power supply to make sure it's getting a constant voltage to the X-ray source. If we're not getting a constant voltage, we could see the X-ray source flash back and forth like a light bulb where you're not getting constant power. So this picture to the right on the top with the digital voltmeter shows a 12 volt DC. And what we're testing is actually the connection from the power supply on the cable to the X-ray source, and testing that there is 12 volt, a constant 12 volts. And then we're also actually testing on several other pins to see that 12 volts turns on and off basically when the interlocks are interrupted. So motion and manipulator, down on the bottom, we're looking at limit switches for the XY stage sample motion and Z-axis. So this is one of our prime cabinets, the internal. There's a limit switch as it moves to the far left or the far right. That XY limit switch stops it, keeps it from moving into a hard stop, causing any kind of problems or running into something that's not supposed to. We also have a Z-axis, usually on systems where the Z-axis either moves the detector up and down or the source or both. And we want to make sure all those limit switches work correctly and that the motion is safe on that and there are not points where somebody, or a hazard where somebody could be injured. A big thing too, again, safety interlocks. It always comes back to interlocks. Do the x-rays turn off when the system is, when the door or the sample door is open? So again, as I pointed out earlier, we were talking about those interlocks. This happens to be on a legacy verifier system. In the top left corner of the opening of the door, it shows a push button interlock. And then on the bottom, you have the door BRH, which goes to the high voltage of the X-ray source. Both of those have to, again, be engaged for the X-rays to energize. If the door is open, the X-rays turn off immediately. You need a current and a voltage, and that shuts that off immediately. They work independently, but they both have to be engaged for the X-ray source to turn on. That's a dual interlock system. It is a fail-safe. And then we also talk about panels. If there are panels on the system that can be accessed, those panels have interlocks on them. Those want to be tested too, and then they shut off the X-rays immediately if that panel is open and it's a hazard. So we've got the safety portion out of the way, or the safety for the cabinet, and we wanted to talk about the resolution of the system. So we wanted to make sure the system is performing to its original specifications. So over on the right side, we have this labeled line pair gauge. What a line pair gauge is a gauge that has line pairs per millimeter. As at the top, those lines move down. As you can see, they get smaller and smaller on that with the number down to the 20. As they converge, and you can see farther down that line pair gauge, you have a higher resolution. In cabinet X-ray systems, we measure resolution by line pairs per millimeter. And most all systems have a specification of line pairs per millimeter. So when we do a PM, or a service technician does a PM, we do a line pair resolution. We use that, and we do it before we start the PM, and then we do it after to see if there's any changes or we can make improvements, also to make sure it's working in specification. We archive these images annually or semi-annually, depending on your PM. When we archive those images, we can see if there's any degradation from year to year from the PM services, and that might be a cause of an X-ray source, a detector, a camera system that's not operating to specification. We also want to make sure the system's, the X-ray source is aligned or in alignment. So from the X-ray source to the detector, that they're in line, meaning if we look at something, an object in the center of the screen, that if it's a round object that appears round, it doesn't appear elliptical or deformed on that. That could be an indicator that the X-ray tube and the detector are not aligned or they're offset. We don't want that. We want to have objects appear as true shapes. And then finally, what we look at in this is we look at a clean image. And the clean image, if you look at the center image here where it says burn detector, we want to make sure there's no artifacts that could obscure what the sample that the operator is looking at. Well, this happens to be this image. The X-rays were turned on for a very long time, and it has a burned circle and a dark circle in the center of the phosphor of the image intensifier. So if you were to look at an image on this, you would always see this shadow, similar to a burning when you burn an image that stayed on a CRT monitor for a long time. So this won't ever be able to be removed. and it'll make it very difficult to do kind of any inspection in the center of the screen. So we want to make sure, like I said, that the image, when there's nothing, no sample in there, is clean and free of artifacts. And finally, in our PM, or the portion where we're doing tasks, we're going to do a radiation survey. We want to make sure it follows that code of federal regulations 1020.40, and the radiation limit is less than 0.5 MR an hour at 5 centimeters from any surface on the cabinet. So we use a radiation survey. This happens to be a Fluke 451B ion chamber that we use to survey. We also use what we call a RAD-IG on that. And to the right of it, we have an actual radiation survey for one of our TruView Prime systems, where this is, we're looking at 22 points of the system, or that meaning the top, front, back, left, right, and bottom. And we're exposing, or we're doing a radiation survey with the X-ray source at max power, max current. And then we do an entire cabinet and then measure each of those points, making sure that all of them are below that legal limit of 0.5 MR per hour. What we find in our cabinets, in most legacy systems, is that we are actually looking at ambient or background radiation. If you were to place the radiation survey meter next to the cabinet at the 5 centimeter mark, you're going to see no change whether you moved it, outside, and the same ambient radiation that you're getting. So cabinet X-ray systems are very safe on that, as the exposure compared to, say, you were to go to the dentist and get an X-ray of your tooth, or go to a doctor and have a chest X-ray, where the X-ray photons and the radiation are penetrating through your body. After that, we've completed the task on the system. We usually, if we have time, what we like to do is do X-ray training for the operators. And what we do with that is we explain, again, the X-ray theory, where the X-ray tube is located, how the manipulator works, how the X-rays pass through the part, creating X-ray photons, creating a shadow on a detector, either an image intensifier or flat panel detector. That's turned into a gray level scale, either digitized or picked up by a CCD camera, and then piped over to an image processor. The image processor then takes that and puts that into real time, where a user or operator can look at the images and look for possible defects or issues, or also do measurements. So we go through that with this training and basically refresher on how to use the system. And if they have any questions on safety, or any questions about the system in general. But we also like to take their samples and put them in the X-ray system, or what they're using to inspect, and give them a little re-education on how to inspect those, or how to best techniques. And then we also sometimes learn a lot from how they inspect them, that maybe we can use that in other system training. So if for some reason during this process the system needs a repair or an upgrade, as we said, maybe the X-ray source is not performing to the correct specification, we can do a replacement, or we could do an upgrade depending on how the system and the cabinet's configured. We can also talk about replacing a detector and a camera, as we saw that burn image on that image intensifier. This happens to be the image intensifier right here. That burn image, that's not going to be able to be repaired, and we would recommend replacing that if the customer continues to use it, and that in that inspection. We can replace the CCD camera or the flat panel detector, depending on resolution or what the customer needs. And finally, of course, the safety repair parts. If an interlock's not working, we need to replace that immediately so it meets specifications and meets both the state requirements and federal requirements for safety. We replace control boards so the system works properly, wiring harnesses, and motors. So all of those safety or repair parts need to be replaced to make the system work to specification and operate safely. And finally, we talk about upgrades. So a lot of the systems, I had spoke to this before in my last presentation, a lot of these legacy systems we have are running Windows XP 7, 8, and aren't compatible with the network that's currently being used. So they need to upgrade to a Windows 10 system. So that gives us the network compatibility. We also give you the improved analysis, improved archiving, with the Windows 10 platform and newer features on that. So sometimes we talk about upgrading the image processor. And then finally, you can able to track your time spent on your TPS reports. So with that being said, to PM or not to PM, this really isn't a question. Yes, you want a PM. The question is your PM current? And if not, why? And you can reach out to me again. I put this for more Office Space references. I use the same one, so I hope somebody got it this time. I know Bill got it. And and you can reach out to me at dphillips@creativeelectron.com, our support team at creativeelectron.com, and our phone number. So we're ready to take any questions, and I thank you for your time.
Thanks, Dave. I actually have a few questions here on the chat line. First one is, can we buy our meter on eBay? Or I think this reader is saying that he's seen meters of several different prices, and he was wondering each one works if any of them work for an X-ray machine.
Well, I can't say to what the performance of each one, just depending on is. I would be very leery of buying something on eBay. We actually have a presentation about compensated survey meters and and what the proper one is. They do need to be annually calibrated and by a certified traceable calibration house, which we do on that. So like I said, it's kind of like buying a used car, and if it's not the proper meter, I think buyer beware, caveat on IMTOR on that. Like I said, this is where you want to buy from the manufacturer.
So give you a call if they decide to buy a meter to look at X-ray.
It's a very important, and we're talking about safety. And if you're audited, like I said, I showed you with that state, I have the chance to, you don't have the proper meter and it's not calibrated, then there's another violation. So,
okay. Another question, the regulations that you mentioned earlier in the US, are they the same internationally, or they vary country by country?
They vary country by country. In general, you look at, this is a generalization, but like Europe, the regulatory requirements, usually they have a CE or TUV, and they audit it, and it can be country by country. And also they use sieverts for their measurement, and usually just in general, a lot of the countries use one microsievert for their radiation exposure. And like I said, in Mexico, they're using 10 centimeters from the surface as opposed to 5 centimeters. So like I said, it is going to vary from country to country.
Okay. But that's something you take into consideration when you...
Yeah, absolutely. Depending, if we're doing PMs in this specific country, we go to their regulations and make sure we're up to date on that.
Cool, thank you. One more question here. what you do if equipment has cracked window. I hope it's something you cover.
Don't
I
use
hope it
it.
doesn't it's not happening to the person who asked the question, but what do you
Yeah.
do if you have a cracked window?
The cracked window. So cracked window is, I would just from in general, I wouldn't use the system until it's been tested. What we do see is that X-ray glass is that leaded glass is kind of soft. So I do see scratches on that superficial, but if it's cracked all the way through, you don't want to use it. That's a safety hazard. Yeah, don't do it.
Yeah, same also goes to interlock issues, right? Doors are not closing properly. Don't just call us, right? Don't.
Yeah, call us. Yeah, call the professionals. There's no reason to do that. And I mean, you're looking at safety and liability, safety of the users, and then liability at some point too on that. So it just, it's a snowball effect.
Yeah. All right. Thanks so much for your time, Dave. It was great. Always great. Appreciate sharing all this information with us. I hope you had you guys watching had a chance to learn a few things from Dave. And again, if you want to learn more, or if you have a system that needs a PM or needs some maintenance, he's the guy you want to call. We're going to have another fireside chat with the experts next week, Wednesday, 10 o'clock in the morning Pacific time. So don't forget to tune in. And this presentation and Dave's talk is going to be available on YouTube soon. So go ahead and check back on our website. Thank you so much, and have a great Wednesday.
All right. Thanks, everyone. Have a great day. Bye.
Great restaurant.